What's up? What's up? What's up, everybody? You are listening to the Data is My Science podcast, a show that makes data your passion. I am your host, Dapper Data. Today, we're going to talk about artificial intelligence. Okay, we're going to talk about AI, as some people know it, right? And if you think about artificial intelligence, it can dramatically improve the efficiencies of our workplaces and can augment the work humans can do. Okay, you think about driving in a vehicle where they talk about automating that, right? It's not replacing the humans. We want to work with the machines. Okay. Don't be scared. Do not get scared of the machines. We want to work with the machines. It's an amazing experience, right? But when you think about automated vehicles, imagine a person that falls asleep, okay, over time, right? Imagine a person that is a drunk driver, right? Being able to replace some of those things, that is amazing. Okay, being able to replace a human being that is sitting there continuously. Oh, matter of fact, if a person can work while the vehicle is driving, right? And being able to cut time and have that being more efficient, that would be amazing. Okay. So when AI takes over that repetitive task, right, or dangerous tasks, as we talked about, it frees up the human workforce to do more, to do the work they are better equipped to do. Things like creativity, all right, things like empathy. So being able to do that is amazing. Now, I have brought on a special guest. Okay. And I know I like to say special guests all the time, but this person right here, okay, Dr. Daimler is amazing. Okay. This person has done so much for the AI community, and I appreciate you. So say what's up, Dr. Daimler.
It's good to be here. Thank you for having
Yeah.
me.
Yeah. And so Dr. Daimler is an authority in the artificial intelligence industry. He's been in there for over 20 years. Okay. And he has done so much in the industry. Okay. He has been an author of the forthcoming book, The Future is Formal: How the Best and Worst of AI is Yet to Come. Okay. Definitely look for that. He has also done much in the AI community when it comes down to Obama, and he's been involved in the Presidential Innovation Fellow during the Obama administration, which is amazing, for all the different communities as well. And so, tell them a little bit about yourself, Dr. Daimler.
Right. Well, thank you again for having me. This is a good conversation to have. I think if anybody knows my name, they'll often recognize me from the time that I spent as the AI authority during the last year of the Obama administration, which was a privilege with some terrific people. I look forward to the possibility of doing that sometime again in the future. I've also been an AI researcher at Stanford, Carnegie Mellon, University of Washington, Seattle, and on the faculty. I was also a venture capitalist on Sand Hill Road at a time at a well-known fund, and entrepreneur several times. So in each one of those jobs, there are people that have done those more intensely and longer than I have, but I've been told that I have that combination is rare, if not unique.
Yeah, well, thank you. I appreciate you being on. I mean, it is an honor to bring you on to this, right? To this podcast. I'm sure the audience is definitely going to love everything you have to say. I want to start off with talking about Conexus AI. Okay, being the CEO and founder of a company that is innovative and changing the world in many ways. What are your thoughts? What is Conexus AI bringing to the community? Okay, I did do a little bit of research and was able to understand that Conexus is doing data integration that is machine verifiable, right? Capturing data lineage, right? And I think data lineage, I think data cataloging, right, as well, and building those relationships through transformation and scales, complexity, and things like that. Can you tell us a little bit about Conexus AI and what it's doing for the AI community?
Sure. It may be helpful to look not just at the 20 plus years I've been in and around AI, but specifically the time I was working in the federal government. The privileged position one has in seeing the panoply of difficulties from the perspective of the White House in implementing technologies in general and AI in particular, gave me a view about where the future would companies and large organizations would experience barriers in fulfilling on the promise of AI. That is what brought me to Conexus. There was a discovery in math out of MIT in 2011. It was a discovery in this domain of math called categorical algebra or category theory. This domain, categorical algebra, was a sort of meta math, or is a sort of meta math. It's like a math of maths. So we could perhaps look fondly on the abstract math we all did in school, but I think this math, categorical algebra, is actually a little easier even than calculus. It provides a certain power in the digital age. It's really a more appropriate math than calculus for databases, which is what Conexus.com addresses. The math of relational databases is based on relational algebra, which is just not appropriate for the scale that we are experiencing today. So a lot of people know that data is the new oil and all that. And I feel like people have gotten the memo about the new oil. There's a lot of data being collected, and whatever the metric is, doubling every 2 years or some such thing. 2 years from now, what we know now is only 10% of the data that will be represented at that time. Everybody knows that. What is less known is that the number of data sources is also growing exponentially, or more specifically, quadratically. And so if you have a quadratic explosion in data and a quadratic explosion in data sources, then the data relationships are just unfathomably large. You really can't comprehend the work that we have to do in understanding the complex systems evolving out of having this combinatorial explosion of two quadratic increases. So that's an abstraction. That's a big deal. I can give you a story about how this actually expresses itself in our world. So a particular client of Conexus was the ride-sharing client Uber, the ride-sharing company Uber. Big firm, rich firm, has a balance sheet that, for all intents and purposes, can fund an ideal IT infrastructure. And it has some very smart people, but by reputation, the technical people at Uber have been and are some super smart people. But that did not allow Uber to grow up with an ideal IT infrastructure. Far from it. And that's because, like any organization, but this is a relatively new one, not like the US federal government, like any organization, they're concentrated on the business at hand. They're growing the business. They're growing the organization. They have a primary mission. That primary mission is not an ideal IT infrastructure, right? So, and so for Uber, what that meant is growing up city by city or jurisdiction by jurisdiction. In this case, 300,000 different jurisdictions. So if you have 300,000 different jurisdictions, some of those have a different privacy sensitivity than others. So Uber needs to respect the privacy lattice in their domain that has driver's licenses have a different sensitivity than license plates, depending on the jurisdiction. Or they might have different ordinary daily business questions. How will driver supply match this coming weekend given the weather or the sporting event? Or rider demand, ordinary business questions. They need to ask those questions not just for Washington, D.C. or Richmond. Virginia, but like the whole Eastern Seaboard or the whole US or the whole world. And that they found to be very difficult. They could do city by city, but then they would have to do a statistical comparison that introduced some degree of friction in both accuracy and time. Uber looked about how to solve this problem of bringing together these 300,000 databases, which is unfathomably, that's a very large data infrastructure, but a proxy for data model complexity. And Uber found that the solution was not in computer science. So the solution was not in the existing data engineering tools of Informatica or Ab Initio or any number of the consultancies, Tata, Wipro, Tibco, Infosys, Accenture, that make tens of billions a year in this manual kind of vocational level IT work every year. It's not pleasant work, I will tell you. That data engineering work needed to be solved at the level of math. So Uber looked deeper below relational algebra, and they found categorical algebra as the solution to their problem. They then looked, well, how can we find the leader in the software expression of categorical algebra, because it's expressed in other places. Categorical algebra is what powers smart contracts on the blockchain. Categorical algebra is what powers quantum compilers. If it was not for categorical algebra, we as humans would not be able to interpret quantum computers. So that already exists in the world. It has to exist for these other technologies to continue to evolve. But for databases, Uber found us, Conexus. We happen to be 40 miles north of them, which is fortunate, but Stanford's right in their backyard, but they found us about 40 miles north. Conexus then collaborated with Uber over a period of months to develop the software that solved their problems. To have them tell that they now save over 10 million a year in the alacrity with which they're able to solve these ordinary business problems, including respecting the privacy lattice globally. So that's really the benefit. That's what categorical algebra is, and that's what categorical algebra provides. That's what Conexus does.
No, that's amazing, because I don't think that many companies understand how large data sets, right? And we're talking about not just a single large data set. What you're talking about is providing aggregation of the data, right? From multiple areas, right? You were talking about one city here, one city there, and the complexity that has, right? Not only just searching, but moving data from one place to a location. That's non-trivial, right? Or the challenge of selecting information from a collection of different databases. It's ridiculous, right? It's actually mind-blowing. That's essentially what Conexus is bringing, right? An opportunity to be able to combine all those different data sets and do the right searching, the moving, the querying, things like that upon.
The space of data is well trodden. There are some excellent companies that already address what I consider to be now an old term, big data. That's not the future. The future is in the data models. That's how knowledge is encapsulated. The data about me, my height, my eye color, that I fly out of San Francisco and I'll go to JFK. That's data. The data model is what Delta Airlines bases their business off of. How much do I pay? How frequently do I go? That is special knowledge that only Delta Airlines has. So the data is different than the data model. That's helpful to distinguish in a range of contexts, but it's the data model that needs to be respected for any subject matter expert in the future. Conexus worked with this hospital group in New York City, and I didn't even know this sort of thing was possible. In this one hospital group, they had different definitions of diabetes. No, you're thinking,
Oh
wait,
man.
I'm not a healthcare professional, right? I'm not a clinician or a reasoncher in that domain. But
If I Google diabetes, I would
I
think.
feel like it makes me a little uncomfortable, right? Yeah, that's what we're saying. I should just be able to look up in Webster's or the Oxford English Dictionary and just come up with a definition, right? But how it gets expressed in the real world, and this starts to become making more sense, is that every department, every subject matter expert could have their own uses or their own needs. So in one area, maybe there's a researcher who just cataloged based on an old study the patient data having data by diabetes or not. So diabetes, yes, no. You look at a table, you look at the columns in the table, the characterizations of the rows of data, and it's just diabetes, yes, no. Now then you might have other departments, it could be temporal, but it also could be in context, that might have a different definition. It might not be diabetes, yes, no. It might be diabetes, how did I treat it? Another one might be diabetes, how long ago? It might be diabetes, well-meaning clinicians could say, well, Eric had diabetes, he's now in remission or whatever, we're treating it this way. Might have a big set of information collected about diabetes. So it's not literally that the definition is different, it's that the context and the way of representing it is foundationally different across one organization in this particular case. And why this is important is because the hospital group, not just for billing, but maybe even for patient care, let alone drug research, wants to bring this data together and do some good analysis. This is what data scientists want. They want the data at the rate of their own intuition. They don't want to go to their boss and have to argue for the budget and the time to do some ETL process. So how do I get that data together and not just allow it to stay dark, to use a Gartner term, dark data? That is what categorical algebra provides, bringing that data together so that the clinicians and the researchers can all have their data used in the way that their own meanings are respected. That is only available with categorical algebra. That's special to the data models, not just the existence of the data.
Man, that's amazing. And that actually brings me to a thought. And when dealing, I work a lot in the government industry, and you worked in the government sector as well. And when you think about it, what you just spoke on, it really talks about the differentiation between industries. I feel like, on modeling. Do you think that there is? So I guess it's not a model that's created it one size fits all, right? Do you think that it depends on the industry as well? Do you think that it actually has an impact on how you would change your modeling?
So the data model is driven by the subject matter expert. The integration of the data model is driven by the motivations of the industry. In the transportation sector, we all benefit from the regulation that, as much as people may not like regulation, in one place we benefit in a very big way, and it's in airline scheduling. There is a requirement by regulation that there is a standard representation of airline schedules through this nonprofit organization, IATA, that has us be able to compare Delta Airlines to United Airlines to Frontier or what have you. If we didn't have that in airlines, it would be a mess, and that would be called the supply chain. That's actually what happens right now. I have a friend that was trying to get out some products he was manufacturing out of the U.S., and he's chasing these ships going up to the eastern seaboard with boxcars waiting in port for, how he's saying it right now, up to 60 days. And he literally has a staff of 3 physically calling on the phone each port, or rather staging at each port, trying to get the boxcars unloaded before the ship leaves. And then have to move the boxcars up to the next port. Like, hey, sorry, we missed you in Savannah. We'll now see you in Charlotte, says the ship. This is this is one of the big reasons that the supply chain right now is not so quickly recovering. I mean, it may have gotten a mess regardless, but why it's not so quickly recovering is because you don't have this required imposition of standards for communication. So you have this manual friction involved. So you have to have subject matter experts that will represent the data model, and then you have to have an industry-wide representation or motivation, excuse me, to integrate those data models or cooperate in the communication of those data models. And then, of course, yes, you do have different data models based on the particular needs of an industry. Conexus works with both those companies that explore for energy, whether it's renewables or whether it's classic energy sources, and in energy distribution, utilities and such that are looking about how to make better use of the resources they have available.
So what would you say are some of the limitations that you see from a government perspective? I think about, we talked about this a little earlier, right? Like data tagging, right? It's not even about the 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 data that is real time. I feel like that's a little easier, but querying and finding all the ridiculous amount of data that's out there, right? There's definitely no problem with data creation in the government. Absolutely, right. It's everywhere and anywhere. There's data that can be collected, but I think of tagging. I mean, what do you think as far as some limitations that you see from the government perspective involving AI?
Yeah, I mean this technology of Conexus got birthed in U.S. government funding from two areas. One was defense, the other was the Department of Commerce, specifically dealing with logistics, where data model transformation had to maintain its integrity. You cannot afford in high consequence contexts to have 4 become approximately 4. Right? You have to have 4 before every single time, regardless of the cloud provider, regardless of the computer language. You can't get that misinterpreted. No, it's not so much about the data, it's about the data model. The integrity of the data is being addressed, and it's being addressed in other ways. But the integrity of the data model, I'm going to call that the semantics, to use kind of the nomenclature of appropriate to this space. The semantics of the data have to be maintained, and the guarantee of the maintaining of the semantics is what is uniquely provided by categorical algebra. I mean, that's really the point. So if we think about in government, we think about sometimes the formulation of regulation. You have to prove that you are doing a pseudo-anonymization of customer data, for example, with the latest addition to GDPR. You can't approximate, you can't think you did, you have to prove that you did. Right? That's the data, those are data models. That's really where the hard part is in the future. For professionals, the tough part, the part to be mindful of in the future and for all of our careers, is to make the implicit explicit. That's what we're going to be doing next. So for the next 5 to 10 years, everybody is going to start putting in explicit language what they're already doing implicitly. And this is in the government sector, whether or not you're a government worker, whether you're a policymaker working on the regs, or whether you're affiliated or somehow working with the government as a contractor or have some other affiliation. You're making the implicit explicit. You will have to do that. The people that will get replaced will be those people that really refuse. And you can resist it all you want, but there will be very, very few jobs that will maintain their relevancy if you can't augment your reasoning with these automations. A couple of the anecdotes are about empathy. That's completely true. So you definitely want to be working on empathy, because that's going to be the last, if we ever are able to replicate it. Empathy is really uniquely human.
That's probably one of the toughest challenges. Would you say that?
Well, I don't think people need to really work on that for a while. There's a lot of other low-hanging fruit before we start working on automating that. The other part is there are some jobs where they will take some machine learning to automate. So the fun story that I had heard recently was in this manufacturing context. this worker that had no formal training, so no graduate school, no undergraduate, not even a high school degree, had spent so long in this one manufacturing this factory that by hearing the machines,
Mm-hmm.
to have my friend tell it, 9 out of 10 times when he would ask for some preventative maintenance on something, he'd be right. He went into retirement, and suddenly the maintenance budget exploded until my friend says, "Hey, that's because Frank retired." And
Yeah.
they bring the guy back, and for somehow like $400 an hour, he walks the floor once a week, just listening to the
Oh my
machine.
goodness.
And he's happy to do it, and the factory's happy to do it, and he just listens to see whether or not to do it right. So how you solve that problem is you bring a microphone around to train the machines on what he hears. But until that happens, Frank's enjoying his retirement
Yeah.
with an increased hourly rate, and those are the sort of things that cannot be easily automated. So if you can't make the implicit explicit, that's a weakness. But everything else we're going to be doing for the next decade is we're going to be transferring implicit knowledge into explicit rules.
Man, that's amazing because, and I love that story that you gave, right? That example. And there's so many other examples out there that can explain how we're trying to tackle this human problem, but there's certain things that we have to spend a lot more time on, right? Massaging and things like that, right? To be able to tackle it. One day we'll get there, right? But it's difficult. I think it takes time, and patience, right? We're trying to get there so fast, right? And to the novice folks out there in the audience that really enjoy the possibilities, right? There's a lot of deeper technology aspect that goes into that end goal that we're trying to get, right? We hear a lot about the possibility of being able to control whatever the human brain can do. That's great. It's amazing, but it takes a lot of training, I guess, for lack of better words, right, to get to that point. So what, from your aspect, right, as being a thought leader, innovator in the IT space, well, specifically AI space, are we getting too far ahead of ourselves, when trying to solve this huge science problems with AI and ML, right? ML, machine learning, for those who don't know. When we're looking at this entire life cycle, right, from ingest to output, right, and there's so many things I feel like that we have not mastered yet, right? AI ethics, cleaning the data. Can we do that in parallel, or are we jumping too far ahead? What are your thoughts on that?
I think we're actually getting distracted. It's not
Mm,
necessarily that we are getting too far ahead of ourselves. It's that we're just focusing on the wrong thing. I think deep learning it deserves the reputation it has. It's super sexy. It's fascinating that those algorithms solved the problem of beating a human at the game Go. That's
yeah.
very cool. And that's a subset of machine learning that when I was growing up, I had a fantastic run. And machine learning itself, as being a subset of AI, leaves out a different part of AI, which is deterministic AI. I'm of the belief that the best implementations of AI are going to use a combination of deterministic AI and probabilistic AI, of which is represented by ML and its subset of deep learning. That combination of deterministic and probabilistic AI is the level at which we need to step back and take a look about where we want to solve these problems at the right scale initially. I think where people may have gotten too ahead of themselves is just being too fascinated by deep learning and too fascinated or even misinterpreting what it meant to have big data. Big data came from deep learning because deep learning requires traditionally these very, 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 very big data sets. So if you are a Google or if you are a Facebook, or if you are an OpenAI where you have something that's the scale of the internet, great. You can go for it. But for the rest of us mortals that do not do not run Google, they do not have the internet scale data. It's completely inappropriate. And to use then the tools that those companies use to solve our more modest objectives is misguided. Is a polite way to say it. We need to focus a little smaller. As much as I said at the beginning that we have a quadratic explosion of data, quadratic explosion of data sources, and these data relationships are important. We need to be thinking a little smaller initially about exactly what problem it is that we want to be solving, and then scale up from there. The issue of bias and ethics is a really important one, but that's also a place where we can be a little more careful about our language. Separate out the data, which can have biases, from the model, which can have its own biases. Data and data models. Take those apart.
You're right.
Data model, models always have biases. They are by nature biased by their creator. I was given by my in-laws this model of a boat. And this boat is a model. It's a scale model. So it doesn't represent everything one-to-one, because why? It's a scale model. That's the nature of models. It's biased. It's biased towards the creator. It has more detail in some places than others. What we want to do is we want to expose it so everybody understands where those biases lie. And then we can just relate to it. Like, okay, it's biased in this way, biased in that way. And then we as a society, we can judge about where we want those ultimate decisions to rest. Because, that's just the nature of politics, is we allocate resources. In a scarce resource environment, we allocate resources. But there's another part of bias that is little appreciated, which is the absence of data. So Conexus works with some of our clients on GDPR reporting and ESG reporting. And that reporting, so it's a environmental, social benefit, right? So we can do that reporting for some of our clients with data, these very large data sets, in the developed world very easily. There's a lot of data available and data models are pretty sophisticated, but in the developing world, it's less available. So it biases the reporting. To say, well, how are we doing in those countries? Or more to the point, how are Conexus's clients doing in those countries? Well, that's actually a little harder to represent. And we need to, how do we extrapolate? How do we represent that in a way that's a fair representation to the people that read these sort of things? That's a type of bias. So you have bias in the data, bias in the model, and then bias in the presence or absence of the data and the data model itself.
No, that is amazing, and that made me think about, going through my process of, different theories, right, meta theories and things like that within the PhD study, right? You're thinking about, it made me think about selective exposure versus mere exposure theory, information gap theory, things like that, and how bias can be intentional versus unintentional, or vice versa, right? And so we tend to think of bias as, especially I'm assuming in the AI community, when you're creating these models, right, you're thinking, man, this is intentional. It could just be lack of information, right? Somebody that just says, hey, look, I know what I know, and so this is the model I'm creating. And so it may seem biased, but it's not intentional, right? So I guess I'm just saying, get off of certain people's back, right? Who think that way, But that is an amazing point that you brought up that I really never thought about, right? And I think about AI security. I think about human rights, biases, things like that. The COVID-19 pandemic, has caused this adoption of AI technology to really accelerate. But I remember hearing a recent report that showed industry leaders, especially in the government, decision makers are saying that that we are moving too fast, right? I don't know if that is because the government is always behind or not. Do you hear the same thing? As far as the government saying we're moving too fast in AI, or is that just because they're behind? I don't know.
I am careful to paint too broad a brush, because about all government agencies and all government people, I had a really good experience with the smart, dedicated professionals with whom I worked during the Obama administration and the Obama White House. The role that I have has actually been elevated, where there's now an AI office inside of, colloquially known as the Science Advisory Group, and that group itself is now a cabinet level position, reporting directly to the president, where it had previously been reporting to the chief of staff. That group of people is really serving the American people well. I know many of the people there today, leading it. I know the leader of it and some of the people working in it. They're really fantastic people. But I can call out the City Council of New York as being over their skis. They, or at least so last year they introduced this. I don't know what you call it in the city of New York, a bill to be signed by the mayor at that time, de Blasio, requiring companies to disclose whether or not they had an automated system for reviewing resumes. I mean, that's just stupid. They need not be thinking that they can add value there. And the reason it's dumb isn't necessarily because we might not agree that we would like to have disclosure around automated systems, but it's careless to be instituting these requirements without some deep thought being put into how that disclosure is even going to be interpreted. We often are exposed to disclosures that may really not help our day-to-day experiences. We have end-user license agreements on every digital artifact we use. Have you ever read one top to bottom? No. We have different cookie warnings right now on all of our browser, and those have different levels of obnoxiousness, I'll call it. But how will it be expressed for people if they just get told that they have an automated system? And what does that mean? And is it good or bad? I don't know if it's any worse to have an automated system reviewing my resume than some essentially call center worker. I mean, it could just be just a big group of people that are going through a lot of resumes. Like, how's that different?
There's somebody behind that machine, right? That's eventually that's somebody that's saying, okay, that's helping train the model, if you will, right?
Well, that too. Yeah, that too. It's a person doing the model. It's the person doing the data. I think better is let's just require in some context that these data models get exposed and audited. That's what I would do. I mean, there's other suggestions I've given to the government, but the public one of the public ones that I exposed in an open letter is having these data models be open to review by people like me, or people that are knowledgeable in the art and can represent what this data model is actually doing, and is it doing what it said? Are we fairly reviewing people's backgrounds or not? For example, that's a more intelligent way to go about it. But so in general, I think the people in government, I've had good experience with being well-meaning and hardworking, serving the interests of the American people. But in that one particular case, by the City Council of New York, could have done better.
No, absolutely. And I'm sure there's other cases, where trying to implement AI too fast because you're coming up with some random way to implement it and say, hey, look, I checked the box. I'm using AI here. That's amazing. You grab some developers, you grab some data scientists, and you just go to work. And you're kind of solving problems that really, there's probably better problems to be solved out there in New York, right? Specifically, or just in certain industries as well, But, we talked about the government. I want to take a little bit of a step back, or maybe it's forward, right? Thinking about the future. There's a lot of universities that are playing a big part in developing solutions, right? For the military, for the government in general. They're developing so many solutions. They're helping out in regards to machine learning AI. How can universities begin to assist more in tackling some of the AI problems that are out there that you see?
I think the future is going to be owned by those that can encapsulate rules in modules of knowledge, and then reconfigure those modules in different contexts. We might call it compositionality or composability. These compositions would differ from modularity, in the same way that maybe a train is different than the train system. For a train, you can swap in and out box cars, and this is the way we might have thought about it in the past. But the composability would be like a train system, where at any one point we can expand infinitely. This is, I think, what needs to be taught in universities. We see these expressions right now with such things as even Minecraft, but also smart contracts, as we talked about, where you can build upon things that have just recently been built.
Yeah.
We see expressions right now with NFTs, and maybe these modules can even be themselves NFTs. We see expressions in direct-to-consumer products. Why is there this explosion of direct-to-consumer products? And it's because these modules are now represented as individual businesses. I can outsource my fulfillment, my manufacturing, but also my customer analytics and my sales. And Shopify takes care of a big part of my e-commerce tech stack. That has allowed for this Cambrian explosion of businesses. The creating of these modules starts with people understanding what the business rules are, and then we encapsulate them in the syntax of computers, and then redeploy them in these patterns. Auto-poetic patterns, kind of auto self-creating and perpetuating patterns. It will be a skill for the future that I think universities will be well served to teach their students.
Are we teaching that in universities now? I mean, you being involved with teaching in different universities that have definitely contributed to the AI community. Do you see that as something that should be a curriculum in every university, or are we getting there?
Yeah, I mean, the math of compositionality is category theory or categorical algebra. You might think the more math, the better. But if I were to choose for my kids or my earlier stage career, I might want to replace geometry, trigonometry, even calculus with a math that's more appropriate to the 21st century. Probability and categorical algebra.
Man, that's amazing. It's always amazing to talk to a thought leader such as yourself. I appreciate that. So I want to, start to wind down a little bit, and I want to get into, your thought process, right? When we think about getting your PhD, we have these thoughts, right, about the future a lot, right? We're able to articulate, how we believe the future would behold to our craft, right? Or so when I think about AI, right, I think about two specific industries that I really would dive into if it was AI right now. And I mean, maybe I'm just piggybacking off what I see a lot, right? I do a lot of reading. I think finance and I think healthcare. If from your perspective, what do you see as two industries that if it could only be two industries that you would dive into, that you would focus in on when in regards to AI?
So this is actually a more nuanced question today than it might have been not so long ago, where there are some obvious places to attack the healthcare life sciences system, both in research, drug discovery, and in delivery. Conexus works with this one company in healthcare in billing that processes 1.4 trillion transactions per year. So clearly a lot of data, right?
Right.
And that sort of data, it represents data velocity. It represents a sort of phase change, solid to liquid to gas, that you have to relate to that volume differently than you did not so long ago. So there's some obvious places to apply some of the modern techniques in that case in kind of the back office, but also in the clinical practice, also in research, and we touched a little bit on those. And in finance, the same thing. I think the we call it the disintermediation, but it's probably a little more than that. Of many of the big players in the financial system, continues apace, and I think that has some long legs to it, and that's consistent with this modularization or encapsulation of business rules that can be then redeployed in different contexts. I'm very optimistic for the many different expressions we may see in financial services over the next decade. But where Conexus is finding a lot of interest is in, believe it or not, some of these traditional industries, such as manufacturing, such as energy discovery, and then energy distribution. And the reason is because these are high consequence contexts, like aerospace. You can't afford to really have any errors, right?
Right.
These have to be bottom up. The future really holds a way in which these systems will be bottom up, provably safe. Right now we test and retest and test and retest and in some sense hope for the best. But the future we see coming at us right now, where we are applying these concepts of categorical algebra to traditional manufacturing settings and traditional energy companies in these really powerful ways. The leaders in this space are going to be even more dominant, because they are going to be creating these infinitely safer and more scalable digital representations of their businesses, and they themselves are going to have these business rules available to be resold to other players in their industry. So manufacturing, energy, and the manufacturers in transportation and aerospace are the three industries that Conexus sees a very bright future.
No, that's amazing, and I appreciate you giving me your thoughts on that, because I did read something the other day about how important transportation is going to play, or how important AI is going to play in transportation, right? If you think self-driving cars and products of a distant are products of a distant future, right? Smart cars have already made their way to the market, right? They're already here, and I mean, we think about the cool aspects, but I appreciate you giving us some of the things that are really going to matter, right? We don't think about energy as much when it comes down to AI. Like the normal person, we think smart cars, we think everything that they're talking about, all the cool, stuff that we see in the world, right? That's very good at marketing. Advertising might be a good place too as well, but we don't think about energy, right? So I appreciate you giving your thoughts on that. And I always like to close out with what I call a dope nugget or gem, right? At the end of the day, and it's really summarization of what I thought, right? And I want to hear your thoughts on things as well, But when I think about AI, right, it's going to change the world. Okay, it was at one point, I hear different points of views depending on the thought leadership, that we're moving too fast and things like that. But when we get to the point where we're really focusing in on the future and utilizing AI the right way, it's going to change the world, right? Impacting the future in virtually every industry that you can name it. That's what I've gathered from your thoughts today, and the skills that we should learn probably. And I'm in my mind, just thinking about programming languages, right? And that's the skill that everybody has talked about you should learn, but they don't really talk about how important statistics or math is, right? Within it. And I think that that's something that people should understand a lot more. What are your thoughts, based off of today's conversation, or anything you want to share with the audience?
There are 18 million computer programmers in the world.
Right.
Even though I have a PhD in computer science, I don't think we need 18 million and one computer programmers in the world.
Right.
I think the sensibility behind computer science is what people are going to be well served to learn, instead of the syntax of a particular programming language. I think the concepts in statistics, probability, and compositionality through the math of category theory, categorical algebra, is where people are going to be well served to spend their time. I think that people might be happy to know that calculus is going to become a little bit more like Latin. Interesting, intellectual, maybe appropriate for a Hollywood screenplay, but less useful in our day-to-day existence out in a diminishing set of applications.
No, that's amazing. That's amazing. Thank you for your thoughts on that. The audience loves this section, right? We're about to get into a little bit of fun. Okay, doctor, we're about to get in a little bit of fun. I like to do a segment at the end called Overrated Underrated. And this is where I give a series of topics, right? I like the audience to know that we are geeks, right? If you will, for lack of better words, we're geeks. We like to dive into the technology. We always talk the technology terms. We do a lot. We have a lot of fun with that. We can code. We can do all these different things. We're thought leaders, but we do care about some of the stuff that others may deem normal, right? And so I want to hear your thoughts on some of these things. And what I'll do is I'll give you about 6 to 7 to 8 topics, and you get to say whether you think it's overrated, underrated, or right where it needs to be. All right, ready? All right, the printer.
Underrated. I can't. My wife requires us to have a printer at our house. Otherwise, I would just use one at the office. But I can't print a UPS label without one.
Oh, yeah. No. I like that. It's been times where I've needed to print the UPS label, right? It's been times where if I'm going through Amazon, it's great because you can just go in and they scan the code and stuff. But I'm sort of torn myself. I'm tired of the printer, but at the same time, and it's funny because as much of an engineer or technologist I would like to call myself, sometimes I feel like, why can't I figure out this printer, right? Why is this printer beating me up, right?
Ask me for another use case of the printer, and I can't find one. But
yeah, exactly.
Underrated. Yeah.
All right, the radio.
In what context?
So I would say, just listen to the radio in the car versus, nowadays we have, you have your regular radio stations, right? But nowadays you can listen to, your Amazon Music or something like that. You can actually choose exactly what you want to listen to, right? Or even podcasts or whatever, right?
I find that I do still. It's funny. I still do listen to the occasional public radio station, independent of the city I live in. It's sometimes, if I have a rental car, that's actually the context under which I find I'm often doing this. Is if I'm in a rental car, I will often just throw on a public radio station. And
so you wouldn't connect your phone and go through all the.
I will, but if I can't, then the radio goes on. So mildly underrated, I suppose. Not
right where it needs to be, right?
Not quite dead.
Yeah. Okay. All right. Ice cream.
Oh, way overrated. I was recently asking about just about ice cream, and the degree to which we can tolerate ice cream is because it's frozen. If you melt it, it's way too sweet. It just really grosses me out when I've thought about it.
You know what? I didn't think about that.
We're consuming that much sugar. It's kind of gross. I'm really turned off of ice cream. I've liked it, and I don't want to be judgmental about it because my physiology is susceptible as any others, as anybody else's. But no.
All right. Libraries.
I have a love affair with libraries. So the Rose Room in Manhattan, in the New York Public Library's Fifth Avenue branch, it is a special place. San Francisco Public Library, gorgeous. Copenhagen's, if anybody else ever goes over there, Copenhagen's library, gorgeous. My wife just actually bought a book, Libraries of the World. I think libraries are special places. They're changing their use case, of course, but libraries really are special places. I think we would be well served to encourage even broader use as a way of exchanging knowledge.
Oh, nice. Yeah, yeah, I've met some guests that I've had on before that said, libraries they thought were a little overrated nowadays, because you can kind of have that piece anywhere else, and you get a chance you have Audible books, you have you can buy a physical book online, things like that, But I do think there's something to be said about, going to this location where you could, find that book and you could sit down and really read it and kind of get away from everything, right? Your mind is not really thinking about anything else but that book.
I think we also want to respect that not everybody has access to Audible and an infinite supply of Kindle books.
Yeah.
I might have 600 or so Kindle books on my as a subscription, as much as I don't like Amazon. And I have at least that many print books purchased from as many independent bookstores as I can. But not everybody has that privilege. So, libraries still serve a big part of society within the U.S. and around the world.
All right. Okay. Two more. Cats.
Depends on the breed. I've come to find out. There's a breed called Devon Rex that is for me, who's generally allergic to cats, likes, and these are cat dogs in that they are friendly cats. They come when you call them, and they almost behave like dogs, and that they like their owners instead of being disinterested, which is the stereotypical cat.
Oh man. Okay. I didn't know. That's something that I just learned. All right. So last one. Strawberries.
Underrated, love them. In fact, there's a couple of bowls in them right now in our office kitchen. Beautiful berries. Yeah, love them.
Well, thank you. I appreciate you being on the podcast. Audience, you are listening to Data is My Science podcast, the show that makes data your passion. I'm your host, Dapper Data. Doctor, where can they reach you at if there's anything? And is there anything that you're promoting now?
Eric Daimler on LinkedIn or any of the other social media channels, EAD on Twitter. I have a book coming out next year, so says my publisher. But my wife has a book coming out next month. You can pre-order on Amazon on corporate culture called Reculturing. So I'll promote my wife's book.
Hey, you get points for that, man. You get points for that, Yeah, and definitely, I know you mentioned Conexus. Definitely check out Conexus.com.
Conexus.com.
Big businesses, large businesses. It doesn't matter the variant of what size businesses that you're looking for when it comes down to it.
The proxy is for data model complexity is generally number of databases. If it's more than 5, that is an indication of data infrastructure complexity, which is often a candidate for our platform.
And this is kind of off topic. Do you tie into Oracle at all ever?
Of course.
Okay. Yeah. I just left
database agnostic. Yeah.
Okay. Yeah. I just left Oracle, and all they do, right? They're known for databases, right? And so
I've heard
a lot of customers, right? With it. So
the fun fact that Oracle got founded in 1975, 3 years after relational algebra in 1972 really came into its own. Oracle would not have existed if not for relational algebra. That's where the term comes from. And we are just now entering a new epoch of compositionality powered by categorical algebra. So thank you, Oracle. Nice to have been ya.
No. I mean, that's amazing, and it's amazing that you're referencing a lot of the mathematical concepts, right, that are out there, and I think that people need to hone in on that a lot more. So I appreciate you, Doctor. And audience, as you know, you can always reach me at Mr. Dapper Date on any one of the social media platform, and definitely check out my website, MrDapperData.com. And love you all. Peace. Talk to you later.